Now let us move to another topic, that is called AC generator. So we already know about AC. AC means it is called as alternating current. We are very familiar with this because in our daily life we make use of the AC because in our whatever the power that is given to our home is AC. So with the AC power supply, we will use many things, many equipments are operated with the help of the AC. So in currents, there are two kind you can see. There is a alternating current, and other one is called as a direct current. It is simply called as a DC. So you have heard about it, AC and DC. See, I can give an example of one battery. So which stores some electrical energy, and which is in the form of DC, which is a DC. DC means it is called as a direct current. The name itself indicates that it is a direct. Direct means it has to flow in a one direction. So if you take a battery, it has a two poles. It has a polarity. So positive and negative poles it has, isn't it? You might have observed it. Positive and negative polarity is there. If you have a connection, any bulb, the bulb will go. Because the current will flow like this. See, this is the movement of electrons here, like this. The current will flow like this. That is in direction convention current. So, ordinarily you can say current will flow like this. Only flow in only one direction. So, this is called as a DC. But AC means it is another kind of energy. That is AC. AC means it is called alternating current. The name itself saying that it is alternating. It will changes with respect to time. So main difference between the DC and AC is the direction of flow of charges. That's all. In DC, all the charges flow in a particular direction. But when you come to AC, the charges will move in both the directions. That is why it is called alternating. It will change as a time elapsed. So this is two kinds of energies. One is alternating current and another one is a direct current. And what is this? Alternating current generator. It is also very familiar for us. Why? Because today marriage functions cannot run without a generator because after the marriage, each people will enjoy, they will dance and they will play the music, and there will be some sound of generator. So what is the function of generator then? That generator will generate some energy. So what kind of energy it generates? That is AC. AC means it will generate the alternating current. That is why it is called as an AC generator. Yes. Then what is the functioning of that AC generator? How does it work? You might have seen from the outside. What you have observed is it has a wheel and something metallic components, some boxes are there in that machine, and that wheel will rotate. So after rotating, there will be a generation of current. So to rotate that, what they will do? They will pour some. They will fill some fuel in some containers. Because of it, that wheel will rotate. Because of the rotation, it will produce some energy. That's what we see. We are filling some fuel in that, After filling the fuel, the wheel will rotate. It will mechanical work. See, it is rotating mechanically. Okay, mechanical work is going on there. Whatever the mechanical work done, that being converted as some other kind of energy that is known as alternating current. So that is why AC generator means it is a device which convert the mechanical energy. Mechanically means externally you are doing the work. That energy will be converted as an electrical energy. So this is called as a AC generator. Generator means it is a machine which convert mechanical energy, external energy, electrical energy. Okay. So that's why there is a conservation of energy. Mechanical work is converted as electrical energy. Fine. So this is about AC generators. Then can we see any other kind of generators in today's life? Definitely, there are a number of generators you can see. And maybe if I want to name, you can say thermal generators. Thermal generator means generator work with the help of heat. That is called the thermal generator. And you can also say nuclear generator. Some nuclear process will happen there, because of it current will be generated. And then water generator. You know about the production of current. Okay, water generator. And wind generator. Because of the wind, the wheel will rotate. Because of the rotation, current will be produced. And these are the some other types of generation of current. So now let us see the structure of this AC generator. It is very simple, and concept like AC generator you already studied it. That is, I am telling you that torque on a rectangular current loop placed in uniform magnetic field. So the diagram of this AC generator looks the same that we have drawn for that derivation. So let's take two magnets. Okay, there are two magnets, north and south. Now we have placed one coil, rectangular coil, that has some brushes and slip rings, carbon brushes and slip rings. Two slip rings. carbon brushes, and these are called slip rings. It is an arrangement to get the EMF. That's all. You get the EMF. EMF means it is a voltage, and this is a coil, and this is the axis of rotation. Okay. So this will have some shaft. Shaft means it is called as a connector. Okay. To this part, the wheel will be connected. I told you that. So that the wheel will be connected to this rectangular loop with the shaft. You will see it's a connector. So that as the wheel rotates, this rectangular loop will also rotate with the angular speed omega. Omega is the angular speed. So that what happens, the area occupied by this with respect to the magnetic field changes. As this rotates, the number of magnetic field lines which is passing through this area will continuously change. As the magnetic field changes with respect to some area, it will induce us an EMF. So this is what you can see here. See here. The magnetic field lines from north to south here. Now the loop is along this plane itself. Okay? Loop is along the direction of the magnetic field. Now let us see. If this plane is placed with in between the two magnets, then the magnetic flux on the rectangular coil is magnetic flux on the coil is phi b is equal to for a one time if I take BA cos theta, okay. So BA cos theta, B is the magnetic field, A is the area of this loop, and theta is the angle between B and A. See here, now this area is along this plane, that is why there is no angle formed between the direction of magnetic field and this. So that is why this is a BA cos theta. Theta means this is the angle between B and A. And I told you that this rectangular current conductor will rotate. It will rotate like that. With the speed what? Angular speed omega. And if you know the angular speed, you can also calculate the angular displacement. Angular displacement means what? It is nothing but theta. You can calculate theta. How? How means you can write this as BA cos omega t. What is omega t? Is equal to theta. Theta means angular displacement at any time t. T can be any value, any time. You can put any value at the time. So phi b is equal to BA cos theta. That is equal to BA cos omega t. So this is what you got here. Then if the magnetic flux linked with this is this much, BA cos omega t, then what will be the induced EMF here? Whatever the EMF induced there, then induced EMF is from Faraday's law. From law of Faraday, E is equal to minus d phi dt, right? If you are writing this is for n number of turns, then what you have to do? You should write this is for n number of turns. For n number of turns, you write like this. So minus what you have to write? D by dt of n d a cos omega t. Okay, now take the n b outside, is a constant, variable is this one, omega t, theta is a variable, that's fine. So n b a, differentiation of cos is minus sign, already minus is there, minus into minus, plus, That is why this is sine omega. So this is the equation for EMF induced in a rectangular coil, which is placed in this this arrangement. Okay, I mean in this rectangular coil. So that is E is equal to NBA sine omega t. Okay, now omega t means it is nothing but theta. Now what is the theta here? Theta is here theta is 0 because theta is an angle between B and A, right? B and A are along the same line. So it is 0 now. So let's say this, if it is rotated to an angle of 90. You have to imagine, see here, along this plane, now I am rotating, see. Now the angle formed between this area and the direction of magnetic field. See, this was the area. Okay, this was the area was like this. Then if you take like this, angle formed here is, it is 90 degree, this is the area, this is the direction of magnetic field, angle will be 90 degree. So if it is, angle is 90, if angle 90, what do you get? E is equal to NBA sine omega t. 90 sine 90 means 1 maximum. Along this direction magnetic field and area are on the same plane, right? So angles, this is the direction of area, magnetic field also. Angle is 0 here. So 0 is EMF is also 0. If the plane is like this, then there is a EMF is 0. Okay, let me picturize in a waveform, in a waves. This wave is called as a sine wave. So initially, when it is along this plane, it was a 0 here. Okay. When it was rotated like this, angle is 90 degree. That is why EMF is maximum here. So maximum, top one, maximum. This is the axis of EMF. Okay. This is the time axis. Or you can take theta also. You can take theta, or you can take time. Anything you can take. Okay. Again, it rotates like this. After that, again it will come back to this position. So it completes a 180 degree. Okay. Again, it is along the direction magnetic field. Again, it is going to 0, right? It will come back to 0. Again, what will happen? Again, if it rotates to 270 degree, again sine 270 maximum value. Again, it is a maximum value. Again, it will rotate 360 degree. One rotation is completed. Again, sine 360 0. EMF is 0. See here. So this is the alternating current that is produced. Yes. It is alternating. See, once it increases, decreases. Again it increases and decreases, so that it will complete on complete rotation, 360 degree rotation will happen. So this is about the concept of AC. And then why we have discussed this concept here? Because there is a application of inductance here. See, this is an application part of the concept of inductance. So the area is changing here, or the magnetic field linking with this area is changing. That is why EMF is inducing here. So it is an application of concept of inductance. So this is where we have completed this chapter, and in the coming days